Today we're talking about dilations. Go ahead and put your date in the upper right-hand corner of your paper. And a dilation is the last type of transformation that we're going to cover. So let's go ahead and look at what a definition for a dilation is. Dilation is a transformation in which a figure stretches or shrinks with respect to a fixed point, which is the center of dilation. These are pretty similar to rotations in that it's the same idea of a fixed point and then it's moving in or out from that point. The important thing to remember with dilations in the textbook is that the same thing with rotations. The center of dilation, the point at which it's getting stretched or shrunk from, is always going to be the origin when they have a coordinate plane. So just keep that in mind. Dilations have another important aspect. They have a scale factor. So instead of having a direction of rotation and the amount of rotation, so we have a scale factor. And the scale factor is the ratio of a side length of the image to the corresponding side length of the original figure. So think about it as the original figure, if the image was 3 times as large, then the scale factor would be 3. Kind of a simple idea for us. Just it's going to be increasing by a certain amount, and that amount is a ratio between the image to the original. We can write this out using our coordinate notation. We start with a point x comma y on our figure. If we're doing a dilation, the way you would write it out is we're going to take some scale factor k. So we're going to get k times x comma k times y. And that's how you find the new points. Let's try an example problem. So I have my dilation up here. It's going to be x comma y. We're going to change it to 2x comma 2y. And I want to take my figure. I'm going to change by that. So I'm going to draw my original figure. So there's my original figure. And I want to go and perform this dilation. So I'm going to take the points that I currently have and I'm going to put them through this transformation. Point A is currently at -2, comma 3. Now, I know from my dilation I'm multiplying it by 2. So -2 is going to become -4. 3 is going to become 6. So I'm going to go to -4, comma 6. And I'm going to draw in my dot. Now B is currently at 2, comma 4. So again, we're going to double everything. It's going to become 4, comma 8. And so on with the rest of them. Go ahead and take a second and try to find out the last 2 points, C and D, by yourself and draw in, and then go ahead and compare it with what I get. Okay, I went ahead and drew in my 2 points. Double check them with yours and see if you got the same. I'm going to connect my figure up now and I've put my points in kind of bad places, so my figure will be a little bit disjointed, but that's okay. I'll draw it in there as well so I can't start ruining where those points are. I'm going to go through and label them, of course, A prime, B prime, C prime, and D prime. And you'll notice, well, all I've done is I've been focused around that point of origin, and then I've been expanding out from that center of my dilation, right? It's been getting larger on the way out, doubling as we head out. Now, I want you to take a second and look at both of these figures. Are these figures the same shape? Well, yes, they are, right? They're the same shape. One's just a little bit larger. Are they the same size? No. So we know to be congruent, they have to be the same shape and the same size. So they can't be congruent figures. But they are the same shape in different sizes. And that happens to mean that they are similar figures, which means that all that information we know about similar can now be applied to these 2 figures. So just be aware that this is a good thing to know, that dilations create similar figures. So we could create ratios between their sides, like we did in our proportions unit. There is a fantastic summary picture in your textbook that'd be a great thing to just look at carefully before you take your test that's coming up soon. So I'm going to take a quick picture of it for you. Okay, here it is, and this is on page 749 in your textbook. And the reason I want you to look at it is I think it's just a really nice example a quick summary of all the different types of transformations that we've learned. So we have 4 different types of transformations. We have translations, which is when we move things around same distance in the same direction from a fixed point. Reflections, where we're flipping it over a line. Rotations, where you're just taking the figure and you're rotating it around a fixed point. And then dilations, where you're just making your figure larger or smaller as compared to a fixed point. And I like how this particular diagram is a nice job of showing you all of the different coordinate notations for some different common types. I think that's a really nice feature of this diagram. So, good one to look at a little bit before our test. Okay, I'll see you in class.